Hello dear friends, and welcome to the 6th episode of our multiplayer inventory system. Today we are building the stacking function for items that we add to the inventory. Let's get started right away. We start directly with the add item function. We'll make some room first. We have to promote the item to add to a local variable called current item to add because we will change the quantity later. The setMembers node can only make changes in created variables and not directly in the input variable of the function. Now we make on current item to add a break. We hide all unnecessary pins because we only need the pin item data asset as a soft object reference. Then we load the asset with load asset blocking. After the asset is loaded, we call the isItemStackable interface. Promote the stack size to a local variable called itemStackSize. Then we make a branch and check whether the item is stackable or not. Create a few reroute nodes. If our item is not stackable, then we go the way of find empty slots. If our item is stackable, then we look for slots that already have this item and still have space. To do this, we pull in item slots. We put it in a for each loop and use it to go through our inventory and check the requirements. We take the slot out of the for each loop and promote it to a local variable. We call this target slot. Now we create a new function in our blueprint function library that checks the requirements. We open our bfl_inventory under inventory system, then library. We create a new function, isStackable and have space. This has two input values. The first is the target slot of type sInventorySlot. Expand this and set pass by reference. The second variable is slot to stack. This is the item that we want to stack in the target slot. This has the same data type. Expand this as well and check whether pass by reference is set. It is set because the editor has copied the setting from the target slot. Then we have an output, which we call result of type Boolean. Now we move the return node to the right. Now we take the target slot pin and check with isSlotEmpty whether the slot is empty or not with a branch. If the target slot is empty, we return a result false as the result of the function. Connect the execution pins. If the target slot is not empty, then we check whether the same item that we want to stack is in the slot. We break once on the target slot and on the slot to stack. For target slot, show the slot index and inventory ref pins because we don't need them. For slot to stack, we only show the item ID pin. Now we load the item data asset from the target slot with the load asset blocking node. After loading, we call our isItemStackable interface and set the return node. Now that we know that the target slot is not empty, we first check whether the item ID is the same as that of the item that we want to stack from the slot to stack. To do this, we make an equal on the two item IDs. We connect the result with an AND node. Connect the isStackable pin from the interface to the second pin of the AND node. So, if our two slot item IDs are the same, and the item in the target slot is stackable, we check whether there is still enough space in the target slot by checking the quantity of the target slot is smaller than the stack size of the item. In the AND node, we add an additional pin for this and connect the pin with the AND node and the result of the AND node with the return value result of the function. Select the function again and make it a pure function. Don't forget to compile and save, and we go back to our inventory component. Now we can check the target slot with the isStackable and have space function we just created with a branch. As slot to stack, we take the item we want to add. This is the variable current item to add. Connect this to the slot to stack pin. Next, we calculate the total quantity when the two slots are merged. To do this, we make a break on the target slot that we take from the for each loop. Then a break on current item to add. Hide all pins except the quantity. Multiply the quantity from the two slots and promote the result to a new variable called new quantity from target slot. Then we check whether the new quantity is greater than the item stack size with a branch. Depending on the result, we set the new quantity. To do this, we create a new function called setQuantityAtSlot. We make this a private function. Put it in the setter and getter category for a better overview. We also move the setItem function to the setter and getter category. While we're at it, we move the findEmptySlot function to the search category. Select our setQuantityAtSlot function again and create an input named targetSlot. This has the type of the structure sInventorySlot. The second input value has the name quantity of type integer. As output, we return the slot of type sInventorySlot. Now we make a break on the target slot. Hide all pins. We only need the slot index pin. Get the item slots variable and use getAReference to read the array element with the slot index from the target slot. It is important that the get is read as a reference. Otherwise, the changes to the slot will not be saved. We now take the set member node for the slot that has been read. Here, we want to set the quantity. Connect the two quantity pins. Now we call our event dispatcher onSlotChanged. Pass the slot to the event by updating the quantity. Don't forget to pass the slot to the return node as well. We set a few reroute nodes. Go back to the addItem function. If the new quantity from the target slot is greater than the item stack size, then we set the quantity of the target slot to the value of the item stack size. We subtract the stack size that we added to the target slot from the current item to add so that we know how much is left in the stack that we still need to add to the inventory. We do this again with the setMembers node. We hide all pins again and only display quantity. To calculate this, we subtract the item stack size from the new quantity from target slot. Write the result to the quantity pin of current item to add. From here it ends, and the for each loop searches for the next possible slot where it can add the rest of the stack. If the new quantity from target slot is not greater than the item stack size, then we set the quantity of the target slot to the new quantity value. If this condition is met, we have distributed the entire stack and return successfully in the return node. After we have checked all non-empty slots and there are still items to be added, we continue with the findEmptySlot function. To do this, we connect the completed execution pin from the for each loop to the findEmptySlot function below. Now we have to distribute the rest of the stack to the empty slots. We don't need the setItem function for now, so we'll put it aside. If an empty slot is found, we write it to the target slot. Then we do a branch. In the branch, we now check. If the quantity of the current item to add is smaller than or equal to the item stack size, then we can write it directly to the target slot. If this is not the case, then we have to subtract as above for stacking and search for the next empty slot. This applies if we want to add an item such as a hammer twice to the inventory, but the item has a stack size of 1. We get the current item to add and promote this variable to a local variable called temporary cache item to add. Call the set members node. Select the quantity pin to change. Drag the item stack size onto the quantity pin. Delete the item to add variable from the graph because we no longer need it. Connect the modified temporary cache to the item pin from the set item function. The target slot variable to the target slot pin from the set item function. If we now follow the example with the hammer item, we have to subtract the hammer that we just pushed into the empty target slot from the current item to add. To do that, we get current item to add as get again. Call the set members node. We want to update the quantity. To do that, we get current item to add as a get again. We then make a break on it. We only want to read the quantity. We subtract the quantity from the item stack size. We write the result back to the quantity pin of the current item to add. Now we still have a hammer left and have to look for another empty slot in the inventory. So we go back to the find empty slot function. For the sake of clarity, we connect the execution up here. Now we have to say in the branch what should happen if the quantity of the item to be added is less than or equal to the stack size of the item. In that case, we push the complete item directly into the slot. Get the set item function and drag it onto the true execution. Drag the target slot variable onto the target slot pin of the set item function. Then the current item to add variable onto the item pin. Move that. Move the whole node around a bit to keep it clear. Now add a return node after we set the item and result as successfully a true. Add a comment to the lower part. It reads, add items to empty slots. We comment on the upper part. Check for slots in inventory with same item and item is stackable and slot have space for more items. That's it for our stacking function. To briefly summarize, first we check whether the item is stackable. If it is, we search the inventory for slots where we want to add the item. If there are no slots, we search for empty slots into which we can push the item. Before we test it, we have to fix one more bug. We go to the content drawer. In the folder Inventory System, Data Assets, and open the PDA_item data. Here we open the isStackable function and change the size query to 1. This is because the item can only be stacked if the stack size is greater than 1 and not 0. Now let's test it. We press play. Open the inventory and it is empty. Close it and let's use T to give us the items. Now we see that we have 10 stones, 2 hammers that each have 1 slot. We have the roasted meat that has a stack size of 16. Were distributed over 2 slots with 10 and 6 items. Finally, the 25 pumpkins, which have a stack size of 4. These were distributed across 7 slots, and the last slot has a pumpkin. 6 times 4 is 24, plus 1 is 25 pumpkins. We close the inventory and give ourselves more items. Here we see that we have 20 stones stacked, 4 hammers in each individual slot, 32, roasted meat with 10 slots each and 1 slot with 2, the total of 50 pumpkins, which are split into 4 stacks and 2 in the last slot. Now give us more items and we see that the stacking function for our inventory works. That's it for this episode. In the next episode, we'll build the drag and drop function. If you have any questions or would like to see certain features, please let me know in the comments. I appreciate every comment, a subscription, or a like. Now I'll stop talking because the panda is already pushing. Thank you for watching. See you guys next time.